Spongebob, let's go with it 2x minus 4 is 0. We're trying to find out what number x has to be in order to make this equivalent to 0. So we solve for x by isolation. And we found the solution that the number that if you place it here for x, 2 times x would be 4, to the 4, which means 0. Being set to 0 before, our quadratics will be also be set to 0. Quadratics have this look. When set to 0. Solve this, 2 answers. Now, how do we get to those 2 answers? We get 2. And if I had a power of 3 here, a polynomial to power 3, we would look for 3 solutions. Okay, so how do we get those 2 solutions? One method is to factor this into 2 binomials. And remember, each binomial that we factor is actually a single linear equation. So we're actually turning one quadratic into 2 linear equations that are that said when you multiply them, you should have 0. In that case, if you set either linear equal to 0, you'll be able to find solutions for them. So you end up with 2 solutions. So let's start that process. Okay, our first quadratic here is 3x squared plus 8x plus 5 equals 0. I want to turn this into 2 linears by factoring it. And here I don't have to preserve the integrity of the problem. So 3x squared can factor into 3x times x. Now the 5, we have several choices there. We have 1 times 5 and we have 5 times 1. I'm going to start off with 1 times 5. Let's see if that works. This gives me 1x. Over here, this gives me 15x. And the sign is going to be the same, and we want a positive 8x. So same signs, but this gives me a 16x. So it doesn't work. So let's start the process again. And this will be 3x times x. This will give us our first term here, 3x squared. And instead of the 1 times 5, let's try 5 times 1. 5 times 1. Okay, inside we get 5x. On the outside, we get 3x. We want the same signs, and we want a positive 8x. So if I put same signs here, positive, positive, this will give me an 8x. And so this is the right combination. So positive and positive, positive and positive. Okay. Now from here, we'll take each linear, these are products that equal 0, therefore each product could equal 0. So 3x plus 5, we say equals 0. And the x plus 1, we say equals 0. And this will give us our 2 solutions. So subtracting 5 from both sides gives us 3x equals negative 5. And then dividing both sides by 3 is one solution of negative 5/3. Here I'm going to subtract 1 from both sides. And this will give me a solution of x equals negative 1. So those are my 2 solutions. Okay. Number 2. Number 2, we're going to factor this into 2 binomials and continue to set it equal to 0. And we're going to factor the 5x squared, which is going to be 5x times x. Okay. Then for the 3, we have several choices. We have 1 times 3 and 3 times 1. Okay, I'm going to choose 1 times 3, see if that works. So 1 times 3, inside gives me 1x, outside gives me 15x. This says the signs have to be the same, and they have to give me a negative 8x. So if I use same signs, let's say negative and negative, that will give me a negative 16x, which doesn't match. So let's start the process again. So we have 5x times x again, that's our first term. Instead of 1 times 3, I want to try 3 times 1. So here's 3 times 1. Inside here, we'll get 3x, and outside, we'll get 5x. Again, we want same signs to add up to negative 8x. So those are same signs, and they do add up to negative 8x. So we found the right combination between a negative here and a negative there. All right, now that we factored, the factors are equal to 0, we can take each individual factor and solve them for 0. So 5x minus 3 is equal to 0, and an x minus 1 is equal to 0. This solves by adding 3 to both sides. Then we get 5x equals 3. And dividing by 5 gives us x equals 3/5. And that's one of our solutions. The other solution here, when I add 1 to both sides, we're going to get x equals positive 1. And those are our two solutions. Okay, so next quadratic, 2x squared plus 5x minus 3. Okay, we will not need to preserve the integrity of the problem. We'll just start by writing binomials for the quadratic set equals 0. And we're going to factor the 2x squared into the first term of 2x times x. Now the 3 could either be 1 times 3 or 3 times 1. Okay. I'm going to choose 3 times 1 to see 5. So 3 times 1. Here in the middle, we get 3x. On the outside, we get 2x. Now, this says we need different signs, and they need to become 5x. So different signs, I'll choose this right here. But this will only give me a positive 1x. So that doesn't work. So let's try new binomials. 0. 2x times x, which is our first term. Instead of 3 times 1, I'm going to try 1 times 3. Okay. So inside we get 1x. And on the outside, we get a 6x. Okay. We need different signs that will give us positive 5x. These different signs will give me a positive 5x. So this tells me I need a negative first and then a positive. So negative here, and a positive there. So now I have my binomials. So let's go ahead and solve. We have 2x minus 1 set equals 0. And we have x plus 3 set equals 0. Solving the 2x minus 1 for 0, I add 1 to both sides. I end up with 2x equals 1. And then I divide by 2 on both sides. We finish up with x equals 1/2. Over here, let's subtract 3 from both sides. We end up with x equals negative 3. And these are my two solutions for that one equation. Okay, 6x squared minus 4x minus 2 equals 0. Let's factor this into 2 binomials here equals 0. And for 6x squared, I'm going to factor that into 3x times 2x. Now for 2, we have a couple choices. We have 1 times 2 and 2 times 1. Let's see. Let's try the 2 times 1. Let's see what we get. So 2 times 1. This gives me 4x in the middle, and it gives me 3x on the outside. This says our signs have to be the same, and we need to get a negative 4x. Sorry. Signs are different. Signs will be different, and we need to get a negative 4x. Let's see. So let's try different signs here and there. Okay. That only gives us a negative 1x, so that doesn't match. So let's start again. We have 3x times 2x. And instead of 2 times 1, I'm going to try 1 times 2. In the middle, that will give me a 2x, and on the outside, this will give me a 6x. Okay, so we need different signs to give us negative 4x. These are different signs, and they do give us negative 4x. So we need positive and negative. So positive here, and then negative there. We can solve 3x plus 1 set equals 0, and 2x minus 2 set equals 0. When I solve this, I subtract 1 from both sides, and I get 3x equals negative 1. Divided both sides by 3, we get x equals negative 1/3. Here, we're going to add 2 to both sides, and we get 2x equals 2, and divide by 2 on both sides. We end up with x equals 1. Okay. So let's try a quadratic that's a binomial. We're used to seeing quadratics as trinomials, but of course they are smaller quadratics, which are our friends, the binomials. And this one right here would be 16x squared minus 25 equals 0. Okay, so since this is a difference of 2 squares, what I'm going to do is use a square root for the numerator and denominator, for the 16x squared, and for the 25. This will give me a 4x and a 5. Now I'm going to write those into 2 binomials, and we're going to write them as conjugates. So on one side will be 4x plus 5, the other side will be 4x minus 5. And from here, we have 4x plus 5 set equals 0, and 4x minus 5 set equals 0. Solve it for x here on both sides. Then we get 4x equals negative 5. Divide everything by 4. And I get x equals negative 5/4. Here, when I add 5 to both sides, we'll get 4x equals 5. Now divide both sides by 4. And our next solution will be x equals 5/4. Okay, number 6. We'll be factoring the binomial, the difference of 2 squares, binomial. 121x squared minus 225. So let's see if we have perfect squares here. 121 and x squared and 225. Okay. 120 square root of 121 is 11. Square root of x squared is x. Square root of 225 is 15. So our conjugate set equals 0 will be 11x plus 15 and 11x minus 15. and then we'll solve both factors, set equal to 0. So 11x plus 15, set equal to 0. 11x minus 15, set equal to 0. When I solve this, I'm going to subtract 15. This will give me an 11x that's equal to negative 15. I'll divide both sides by 11. And I'll get one solution of x equals negative 15 over 11. If I solve the other side, I'm going to add 15 to both sides. We get 11x equals 15. Then I'll divide both sides by 11. And I'll get a solution of x equals positive 15, 11.